Welcome back to the classroom. My name is Mr. Wong, and today we will be looking at a past paper question. We want to consider the following diagram of this man and this box. So a man is pulling on a rope, and that is connected to a 200 kilogram box. They've applied a force of 160 newtons, and they're pulling it at 30 degrees to the horizontal, or above the horizontal. The question that we have here is to calculate the coefficient of friction between the surface and the box if the box was traveling at a constant speed. So there's a few things to unpack here. Firstly, let's look at the relevant formula to calculate, the coefficient of friction. So we know that friction force is equal to the coefficient multiplied by the normal force. Okay. Now, in this case, the normal force is the component of our gravitational force coming down here, but also the vertical force that we're applying as we move the object upwards. So let's just call this 160, because that's the magnitude we use, and sine 30, that's the actual vertical component that we have here. What you can see is the two forces are in the opposing directions. Now, if this person was pushing, in this direction down onto the box, then we can actually add the force components onto it. But what's actually happening is, whilst this box is making contact to the surface here, they are actually lifting it slightly upwards. So that means our normal force is a component of this subtracted from this, or the other way, vice versa. I'll go into a bit more detail what I mean by that down below. So what I know is the normal force is going to be mg subtracted by 160 sine 30. Remember, the reason why that's the case is although the box is being pushed down, and so we said that if in isolation, the normal force of this box is directly opposite to the gravitational force, that's technically true, but this person is actually pulling the box slightly upwards. So it's not a direct one-to-one ratio transfer. So we need to account for the fact that this person has pulled the box up slightly. And that's why we need to do a subtraction here. Now, the mass of the box is 200 times g, which is 9.8, subtracted by 160 sine 30. Okay, so let's put that into the calculator and actually see what value we get at the end of that. So from there, I find that the normal force applied is 1,880 newtons. So that's part of the question done. Now, the other thing I talked about with the force, or should I say the friction force, or the coefficient, is we also need friction force. So we found normal force, we need to find friction force. Now, if we read this question carefully, it's not actually stated very clearly what the friction force is on the box, but there is some slight information that we can actually use, and it comes from the fact that the box is traveling at a constant speed. Now, if I'm dragging the box in this direction, let's say that's the velocity there. Remember, if an object is traveling at a constant speed, so if it's traveling at a constant speed, the net force is 0. Now, how can the net force be 0 if the object is moving towards the right? Well, that means we've applied a force to the right here. Let's say that's the one that's talking about our actual motion. That means the friction must be obviously acting in the opposite direction, but in the same magnitude. So if I actually find the horizontal component of dragging this box towards the right, then the assumption I can make is that is also what the friction force is, because I am traveling at a constant speed. Hence, net force would have to be 0. So when these two add together, I should get a value equal to 0. Okay, so that's the implication there. You can also think of it slightly as Newton's third law, the way we're applying it. So let's show for that. And obviously this example that we have here, where the net force is 0, but the object is moving at a constant speed, would also represent that we have a dynamic equilibrium. Okay, so that's what we have. All right, so we'll come back down here. So the force component of dragging it towards the right is 160 times cos 30. And the value I get for that, I remember there was quite a few decimal points. So it was 138.540646 newtons. Okay. And what I can actually say is Fx is essentially the opposite of the friction force. Okay, so if I want to write a direction, I can just say the friction force is our negative 138 blah 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 blah. We're not going to really worry about this because the coefficient of friction is a scalar quantity. So there is no positive or negatives involved, so we can just leave the numbers as it is now. Okay. So, final thing we need to do is do our substitution to find the coefficient of friction. So I rearrange the equation. When u is the subject of the equation, we have the friction force divided by the normal force. So the friction force, I'm just going to write the original working out because there's too many numbers to write down, divided by our normal force, and that will tell us what our coefficient of friction is. So the coefficient of friction is 0.07370428968. Now let's see what number we should round it off to. Okay, now in the actual calculations I used, the lowest sig figs was 9.8, which is 2 significant figures. So I can actually round this off to 0.074. Now there's no units for the coefficient, and so that's how you actually do the question. Let's zoom back out a little bit. And that's actually how we do the question. Remember, it was to calculate the coefficient of friction when a box was being slid between a surface with the ground and a person was holding on to a rope with this box, sliding it across. So this is looking at friction forces and also force components. Hopefully this video was easy in explaining how to complete this question. If you found it useful, like and subscribe, and I'll see you next time.